Alright everybody, welcome to the stream. Today we're going to be covering a little bit of WebAssembly. We're going to go dive deeper into a book that was built by Marco and Daniel, right? And today, and I just want to cover the content. So what is WebAssembly from the ground up? It's for Mariano and Patrick. My bad. My bad. So we're going to be diving deeper a little bit into WebAssembly, how to instantiate a module, how to create things, and I wanted to learn a little bit more because we're working with it with the Crunchyroll subs. And I think it's going to be a very good learning experience. I want to share it with the world, and let's dive deep into it. So we're going to go through the book, introduction, and make it a little bit bigger. I actually bought it. I recommend you to actually buy it. I'm going to share the... Gonna come here to my profile, gonna come in here, gonna come and just post a reply. Just for those wondering, this is the book. And okay, introduction. We're pretty excited about WebAssembly. I mean, of course, we are. Who would decide to write a book about something they're not excited about? There's certainly been a lot of hype since the day that WebAssembly was announced. People have been making some pretty wild claims about it. Things like add WebAssembly, get performance, it's going to replace JavaScript, WebAssembly is the future of computing. And of course, none of these are really true. But do you think WebAssembly is a legitimately transformative technology that is worth learning about? You probably do too. That's why you're here, right? And I just want to give my 2 cents about it. Yeah, definitely WebAssembly is not going to be a replacement, especially since it's like very far away from it. I remember that I've been using Injects. I've also used DevTools on Rust, on working with it. I wanted to create like a pet project and learn a little bit about the programming language at the same time. And out of the gate, there's no way you're competing against JavaScript. JavaScript has become one of the best prototyping programming languages that are easy to learn. I think that the two challengers could be Ruby and Python, but JavaScript is a very simple language. Everything else considered, and it's also and I would love to get corrected. I think it's the only language that you don't need anything else like a special toolchain or anything that can be ran directly from your computer that can have some sort of visual feedback. Since it manipulates like HTML directly, you can just go ahead, open your console, and start like doing things, and you can start seeing results. In fact, you can also create like a single index HTML file, and virtually almost every device in the world will be able to render it. And that's I think that's one of the incredible things about JavaScript, and I love it, even though it has a lot of its quirks. And sometimes I would like to get it and throw it out of the window and burn it into like shreds. And I'm just gonna skip a little bit around like what is WebAssembly. So for those who actually don't know, it's like a low-level bytecode format originally designed for the web. It is mainly intended as a compilation target, allowing languages like C++, Go, and Rust to be executed in the browser at near native speeds. And I think, and we're going to talk a little bit about it like later on, like one of the very big advantages is actually about bringing those APIs that were like near impossible to have on the web. And one of those APIs could be like FFmpeg, which is like a transcoder, which is amazing to have something like that. I know Figma uses it, and you're going to talk about it later on. And Squoosh, which I remember they were built by a couple of them. Now I forget about Cerna and Jake from Google. I think they were involved in the development, and they used WebAssembly to create probably one of the best free services for images. It's called Squoosh. Squoosh.app. We just have the live stream in here. We have the chat. And this is a private group. So No, what is this? What is this pop-up? So I'm just gonna come over here. Much, much like machine code, wasm bytecode is a compact binary representation of low-level instructions. The majority of the instructions are basic operations on numeric values. Add, abs, XOR. These are also instructions for reading from, and writing to memory, and some basic control flow instructions called loop if. I've never written machine code. I'm so excited to learn about this. I've only been working now for in the web officially kind of like for 11 years, but my thing like dates way back when I began like dabbling with some books, physical books and PHP around 18 years ago. I'm 33. I began at 15. So let's continue. I'm pretty excited. But unlike machine code, these instructions don't target any specific CPU. They're meant to be portable and close enough to real CPU instructions to be translated as fast and efficient as possible. And that's totally true. Yeah, and like Wasm, that's one of the biggest advantages is that it becomes portable. And I know they're using WASI now. They are targeting for the server, and I know they talk a little bit about it later on. And why I'm sorry I'm skipping through because this is just like the introduction. Why is it a big deal? Like unlike previous attempts to bring native code to the web, like ActiveX, Native Client, or Asm.js, WebAssembly is an open standard that's implemented in all the major browsers. Yes, that's very big important because later, like 10, 12 years ago, no, no, 18 years ago, I remember when I began working on JavaScript, like 2008, 9, 10, it was horrible. I remember having a lot of differences between Internet Explorer, even across versions of Internet Explorer, it would behave very differently. I didn't know at the time why jQuery was very popular, and it was because it actually started as a cross-platform tool, and it just became the inspiration for a lot of things later on, like document query selector. Give me 1 second. The thing is that I have my little boy sleeping. He's a very bad sleeper, and I gotta take care of him once he wakes up. And okay, first and perhaps most important, WebAssembly is safe by default. Its design makes it. Is it better now? Its design makes it easy to verify that a module doesn't do anything it's not allowed to do. So untrusted modules can safely be executed in the same address space as other code. Yes, this is very important. Dun 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 dun. Okay, I think here's where we're gonna start. F11. Come on, Vivaldi. Wait. I love you. Full screen tile. Why don't you go full screen? Oh, Control Shift F. Control Command F. Damn, that's Yeah, I know that's something I really like about Mac OS. Is if you want to go full screen, you got that thing. Okay, let's do it this way. Okay, and step one. Now, to better understand how everything fits together, it might help to look at a concrete example. Figma is probably one of the most well-known web applications that uses WebAssembly. Let's look at what the typical flow might look like. In step one, we got the C++ source code, we got the mscript compiler, and it generates a binary encoded WebAssembly module and a JS glue code. Come on, man, come on, don't wake up, don't wake up, don't wake up, don't wake up, please. The first step is that an engineer in Figma writes some C++ code and compiles it with a compiler like mscript. That produces a binary encoded WebAssembly module, usually with a .wasm extension, as well as some JavaScript support code. A wasm file on its own is not directly executable. It is more like a shared library. That is actually very interesting to know. I thought they were directly executable. In order to actually execute the WebAssembly, you need at least a small amount of JavaScript code. I mean, I knew that I figured as much because that's how I've been using it. But well, yeah. Okay, got it. It makes a lot of sense. So So that means that you always need JavaScript, at least. And I think that the other counterpart would be like something that you drop in the WebAssembly and it executes immediately. And I think they're doing this for safety reasons, because imagine if like a WebAssembly by itself like just downloads into your browser and starts executing. Well, the same thing can be said about JavaScript. So I don't know what they're doing there. Probably they're like a later standard on could just auto execute. Although I don't, we probably don't care because it's that very small JavaScript like makes virtually no difference. And step two, Figma.com, get, we got the wasm.js. And the next step happens when a user visits Figma.com in the web browser. The browser first downloads the HTML, which includes a link to the compiled wasm.js script, so it downloads the file as well. So what's in that file? At a minimum, it will contain something like this. It will contain the source, fetch, I think this is a traditional fetch, compile wasm, the wasm file, and instance await WebAssembly instance instantiate streaming. Okay, here we go. So we're gonna get more into into deep knowledge. So this is web baseline available. Oh, okay, since September 2021. Oh, I thought it was later. That's good. The WebAssembly understands streaming static method compiles into WebAssembly modules directly from a streamed underlying source. This is the most efficient, optimized way to load WASM code. Okay. WebAssembly strict content security policy might block WebAssembly from compiling and executing modules. For more information, so I think that the other part is here. Static method allows you to compile and send WebAssembly code. Has two overloads. Take WebAssembly binary code in the form of a typed array. Oh, he woke up. I think my wife is gonna breastfeed him for a while. If he doesn't just go to sleep, I'm gonna go and look for him. I'll probably have to early stop the stream for that. The return promise resolves to both the compiled WebAssembly.module and its first WebAssembly.instance. The secondary overload takes an already compiled WebAssembly.module and returns a promise that results to an instance of that module. But what is an already compiled WebAssembly.module? Stateless WebAssembly code that has already been compiled by the browser. This can be efficiently shared with workers and instantiated multiple times. So WebAssembly code that has already been compiled by the browser. I'm currently trying to learn more about WebAssembly, and in this URL, wait. I'm currently trying to learn more about WebAssembly, and in this URL, it says something that the browser compiles WebAssembly code. Can you walk me through it? How does that work? And why does the browser compiles it? Because I thought that the browser didn't have to do any compilation step at all. So it says what MDN means by already being compiled by the browser. In plain terms, you start with a WASM binary file. The browser's JS WASM engine v8 in Chrome, parameterized JavaScript core in Safari, takes those bytes and turns them into native machine code for your CPU. Oh. It's just not interpreted bytecode. Oh. All right. I know, yeah, I know. It uses a just-in-time compiler for JavaScript. I know. Abstract syntax tree, and then yeah, it uses one or more JIT compilers. So in here, so basically, the browser is doing the same thing with the WebAssembly. I didn't know that. I really didn't know. But it makes a lot of sense because, of course, that's what it's actually saying here, that it does not produce machine targeted code. It actually created a portable version, right? The basic is rather than producing machine code for a specific architecture, your C++ or Rust compiler can instead produce WebAssembly bytecode. Later, browser will download the bytecode and translate it to native machine code on the user's device. So this is why the WebAssembly module contains stateless web can already be compiled by the browser. This can be effectively shared with the workers. Oh, got it. So this is translation that's happening. Got it. Got it. WebAssembly is already in a compact, validated binary instruction format that is much closer to machine code than JS source. Because it is structured and statically typed, the engine can validate quickly, compile quickly, and generate very predictable, optimized native code. So your assumption, browser didn't have to do any compilation step at all, is a really mental model from very old JS days. Current browser heavily compile both JavaScript and WASM. And here's like a pipeline. Let's walk through a typical path using WebAssembly that instantiates streaming, which MDN calls the primary API now. Yeah, that's what we're saying. This method is not the most efficient way of fetching and instantiating WASM, if at all possible. Which fetches, compiles, instantiates a module in all in one step. Conversion to an array buffer. Oh, so there's like overhead. Got it. Got it. You know, this is one of the few exceptions that I think that they're very expressive to use one method over the other. Because, oh no, like we're in, I wonder, it's been a long time since I've accessed MDN XHR. Oof, it's in July 2015. July 2015. I thought that this was even older. Probably it was because it was supported in like in Edge. Well, whatever. This has been the first time that I've seen somebody like a method being so. I don't know a lot about MDN, but so strong on using something else, unless it's like deprecated. So let's get back at our book. We already now know that what's actually happening is like it's translating, it's compiling that WASM file and generating it into something that the browser can, it would be like machine code that the computer can actually understand. So there's always going to be some overhead, I think, versus like running something directly. Got the step 2 and instantiate streaming. Okay, we already got it. And instance.export and render Figma. Call one of the module's exported functions. It's actually an example, it's not part of it. Remember, a WASM module is not directly executable. From the outside, it's very much like a regular JavaScript module. It exports some functions, which we can choose to call or not. You can, however, specify start function to initialize the state of the module when it's instantiated. Ah, that's good. That's good. A lay of the land. Now that we have talked about a concrete example, it's helpful to zoom out a bit. One of the reasons WebAssembly can be a bit confusing for newcomers is that it's not really a single thing. It's really a collection of different technologies and formats. So it seems we got the web API over one side, the JavaScript interface over the other, the binary format that WASM, got validation, the execution model, the text format thought, what? I've never heard about it. Give me a second. Dot what? Okay. WASM. WebAssembly text format. To enable WebAssembly to be read and edited by humans, there is a textual representation of the WASM binary format. This is an intermediate form designed to be displayed in text editors, browser developer tools, and other similar environments. Oh. This article explains how the text format works in terms of its raw syntax and how it relates to the underlying bytecode it represents and the wrapper objects that represent WASM in JavaScript. This is potential overkill if you're a web developer who wants to load a WASM module into a page. Use it in your code. It is useful if, for example, you want to write a WASM module to optimize the performance of JavaScript library. Damn, yeah, we already know. Okay, so my boy just woke up. I'm gonna go and rescue him. I'm gonna come back. I'm gonna leave the stream like that, and if 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 I can come back in here, I'll probably continue. If not, I'm just gonna stop it here. Guys, I think I'm gonna be closing the stream now. I'll be back.